In section 12.2, number 29 is a suggested problem, and this is a problem like that. If vector v lies in the first quadrant and makes an angle of pi over 6 with the positive x-axis, and the magnitude of that vector v is 3, find vector v in component form. So first of all, what component form is for a vector, which again, we have all these different notations, but if I have boldface v, that's the same as v with a line over it. And we have this notation of v sub 1, v sub 2, and these cool kind of spiky parentheses that the book uses, or the plain parentheses that are boring in Math Insight. And then we have the IJK notation. So that's a possibility as well, where we have I in boldface plus J in boldface, which another one, this is one I used back in physics, I think, is I hat and J hat. Okay, we got a lot of options here, but just a quick review. So anywho, we're trying to find that v sub 1 and v sub 2 is what we're trying to do. So you might look at this initially and say, I have no idea how to do that. Or maybe you know how to do it, which is awesome, but it helps to make a picture here. So we have this vector, we're trying to write it out in its component form, and we know that in the first quadrant, so I'm drawing the first quadrant here, it makes a positive angle of pi over 6, which is kind of something like that. And we know its length, or magnitude, is 3 for our vector v. So this is what we know in picture form. So the components graphically correspond to, just looking at these lengths, v sub 2 and v sub 1 in the x. And so if we just do some trigonometry, this is really easy. We're just going to use right angle trigonometry. So quick review that. Maybe it's been a little bit since you've done exact radians and all this stuff. So anywho, what do we got here? We're trying to find v sub 1 and v sub 2. We know that the hypotenuse of our right triangle here is 3. That's the magnitude of the vector. And we know this angle pi over 6. So it makes sense for v sub 1 to look at the cosine of pi over 6, because that is adjacent over hypotenuse. And our adjacent edge is v sub 1, and our hypotenuse is the magnitude of vector 3. So here we can find cosine of pi over 6. We know 3, we can find v sub 1. So just multiplying both sides by 3, we have v sub 1 is equal to cosine of pi over 6 times 3. All right, maybe you know this answer instantly for cosine of pi over 6, but if not, quick review of that. When we have the first quadrant of the unit circle is one way of figuring this out. Pi over 6 is the first special angle, other than 0 if you consider that special. And so we memorize typically what the x and y coordinates are for this point on the unit circle. And so what that would be for the x component is square root of 3 over 2 for coordinate component. I get those confused. And then, ooh, this is not quite to scale, so it's 1/2 is the y. And so the x component, or x coordinate, I should say, is the cosine of pi over 6, this angle here. And the sine of pi over 6 is the y coordinate. So we only care about cosine of pi over 6 for now, which is square root of 3 over 2. So we can plug that in, and we're pretty much done here finding the answer for the v sub 1 component. Oops. So 3 square root of 3 over 2 is simplified, and we got that result. We're going to play the same type of game for finding v sub 2. But we're going to use a different trigonometric function. We're going to use sine. Because sine of pi over 6 is equal to opposite over hypotenuse. Oops, not odd, but opposite. Change that. And so what we have in this case is going to be v sub 2 over 3. Rearranging a bit, we solve for v sub 2, and we get that the sine of pi over 6 times 3 is what v sub 2 will be. So actually, our in-depth discussion here of and review of unit circle helped us answer that sine of pi over 6 is 1/2. So we plug that in. And we got it, 3/2. So just writing this out in any of these notations are fine. Our v sub 1 was 3 square root of 3 over 2. And our v sub 2 is 3 over 2. Oops, messy. And we're done.